try a nice little word problem right here. It says two angles are complementary. All right, that means they add to 90 degrees. The measure of the larger angle is 10 times greater than 10 greater than 9 times the measure of the smaller angle. Wow. 10 greater, so that'd be 10 plus 9 times whatever smaller angle, right? Small angle. Find the measure of each angle. Well, if the measure of the smaller angle is x, then just from what we have up here, we're going to have the measure of the larger angle is 10 plus 9x. And let's go ahead and figure that out. If they're complementary, they should add up to, add up is the important part, 90 degrees. So I know that 10 plus 9x plus x, right, for the measure of the smaller angle. So the big angle plus the small angle should equal 90 degrees. Let's combine like terms. We got 9x plus x is 10x. We're going to subtract 10 from both sides as well. And what do I get? 10x equals 80 degrees. Or we know that x, divide both sides by 10, we know that x equals 8 degrees. And if that's true, let's look at the big angle. This is going to be 10 plus 9 times 8, which is 10 plus 72, or 82 degrees. And that makes sense. 82 plus 8 is indeed 90, so we are good to go. Awesome. All right, we're going to go ahead and look at this figure for a minute right here. I am going to tell you, so I want to draw a line right here just to separate these areas. Here's what I'm going to tell you. I'm going to tell you that line AC is perpendicular. This is the symbol for perpendicular. It is perpendicular to line DB. If it's perpendicular to line DB, here's what we can say. Therefore, angle A, or the measure of angle AEB equals 90 degrees. And the measure of angle AEB is congruent to the measure of angle BEC, which is also congruent to the measure of angle CED, which is also congruent to the measure of angle DEA. And how can I say all this? Well, watch. If the measure of angle AEB is 90 degrees, AEB is 90 degrees. Right there is 90. Well, these are vertical angles. It makes this 90 degrees. But I also know we have a straight line here, so these should add up to 180. 180 minus 90 is 90, so this is 90 degrees. And again, vertical angles. I can go about this a lot of different ways, but once you have if you have two lines intersecting, if one angle is 90 degrees, they're all going to be 90 degrees. Okay, that's how it works. Take a minute, write this down. We're going to move on to this nice example right here. And it's kind of hard to see, so I'm going to help draw this. You should have a nice little figure that looks like that. And it's hard to read these. They should say 3a minus 27 degrees. And over here we have 2b plus 14 degrees. Okay? And both these lines are perpendicular. So let's read what it says. The lines of the tennis court form adjacent angles with a measure of 3a minus 27 degrees and 2b plus 14 degrees. Find the values of a and b so that the lines are perpendicular. Round to the nearest whole number. Well, if they're perpendicular, they add up to 90 degrees, right? Each one of those is 90 degrees. So then, if I know 3a minus 27 is 90 degrees, well, let's write that. 3a minus 27 equals 90 degrees, right? So I'm going to add 27. I get that 3a is equal to, I'm going to go ahead and move this up. 3a is equal to 117 degrees. Divide both sides by 3. It actually works out real nice. A is 39. Boom. Now let's do it for B. Same thing for B, different equation, but it says this side should also be perpendicular, which means it's also 90 degrees. So I'm going to say, all right, 2b plus 14 equals 90 degrees. Boom. All right, subtract 14 from both sides. We get that 2b equals 76. Divide both sides by 2, and what do we have? That b equals 38. Should square that, I guess. Boom. All right. So good problem right there. Now we're going to talk about things we can assume versus not able to assume from a drawing. So everybody sees this drawing right here of these three intersecting lines. We know they're lines. They have arrows on each end, so that means they're lines. At least for JG and IF, we see that this right here must be a line segment. So let's talk about this. What can we say? First of all, we can assume all points are coplanar. What do we mean by that? They're all in the same plane. There's not anything three-dimensionally going on here. This is just all in the same plane. It's a 2D drawing. We can also say the following are collinear. Following. In other words, make that just one I. Following are collinear. J, E, G. So these points on this line are all collinear. K, E, H. On this segment, these points are all collinear. And last, F, E, I. Each of these points are collinear. They're all on the same line. Okay, we can assume they're collinear. What else can we assume? Points or lines of intersection. Assume points or lines of intersection. In other words, because I drew all three of these lines intersecting at point E, I can assume they all intersect at point E. It's not like it was a bad drawing or something like that. We're just assuming that's true. We can also assume pairs such as linear pairs or adjacent angles. Okay? In other words, I can look at this and assume that these angles are linear pairs that add up to a line. I can assume this angle and this angle are adjacent to each other. They're right next. They're sharing a common side. Okay? So those are things I can assume. It's important to know what we can assume, but here's what we cannot assume. We cannot assume that a point, line, segment, or plane bisects each other. In other words, I can't draw a line like this. This is A, this is P, this is M. I can't draw that and just assume that M is the midpoint. I can't assume that it cuts this line into equal parts. I can't assume that. The only way I know that is if it's defined, if I'm told that. If I just see a drawing that looks like this, I can assume B is in between those 2 points, but I can't assume any distances. It could be that this is a distance of 1, this is a distance of 5. It doesn't matter that it's drawn in the middle. I can't assume anything, okay? I also cannot assume perpendicularity. What do I mean by that? Well, if I look, it almost looks like I have a perpendicular segment right here. That IEH would be 90 degrees. It looks like that. But I can't assume that. Maybe we just drew it that way. Can't assume it. Can't assume congruence of angles. just because this angle, and well, let's see, this angle right here looks perpendicular, and this angle right here looks perpendicular, I can't assume that they're both 90 degrees. I can't make that assumption. Now I can look at this and say they're vertical angles, and that's fine. But I can't assume these two angles look similar, but I can't assume they're the same. I just can't. I have to be told or I have to prove it. Last thing, I cannot assume the congruence of any figure. So any shape, any figure. In other words, if you see a drawing that looks perfect, boom, not that this is going to be perfect, you cannot assume those are congruent rectangles. Clearly they don't look like it, I think. But you can't assume it even if they look perfect. It has to be proven. So these are things we're going to get used to, just kind of giving you a heads up about them. With that said, peace out.